All right, Gipsters, in the last 2 weeks and a half, we've been talking about linear functions. We've been learning how to solve for them, how to write equations. We are now going to be looking at systems of equations. And systems of equations no longer one linear function, but two linear functions in a problem. We are going to be starting out with some word problems. I want you to take notes. So this says Randy and Craig rides their bike in a constant speed. And it does take Randy 25 minutes to bike 4 miles and Craig to bike 4 miles in 32 minutes. Randy does give Craig a 20 minutes head start. I'm going to reread that again, and I'm going to be highlighting key things that I do need. It says Randy and Craig are riding bikes at a constant speed. We know that Randy, it takes him 25 minutes to ride those 4 miles, and Greg, those same 4 miles, it does take him 32 minutes. Greg does get a 20-minute head start. That is a lot of key information, so I actually want to make a little diagram. So I know we are talking about Randy and Craig. So I want to start out with Randy, and I want to put the information that I know about Randy. So I know Randy, it does take him 25 minutes to bike those 4 miles. And then for Craig, I know that he rides those same 4 miles in 32 minutes. And then we also know that Greg does get a 20-minute head start. So now that I wrote all of my information away from the word problem, I'm able just to look at this diagram and be like, oh, okay, this is the information I need for Randy. This is the information I need for Craig. Because that is a whole lot better than looking at that word problem. So let's take a look at my very first question. Assuming he bikes Y miles in X minutes, write a linear equation that represents Randy's constant speed. Well, we know that it does take him that 25 minutes to bike those 4 miles. If we were to set up a constant speed, it will usually be miles per minute. I know since it is miles per minute, I want to take the miles that he did ride. So we know that Randy rode 4 miles. We rode those 4 miles in those 25 minutes. So I know my constant speed is just going to be 4 over 25. So if I were to write an equation, I know constant speed is just like saying my slope. So I'm going to be writing that equation of y is equal to mx plus b. So y stays the same. All I know is my slope, which is 4 over 25. Don't forget my x value. Do I know my b value? No, I do not. Matter of fact, this problem does not have a b value. So I know my equation is going to be y is equal to 4 over 25x. I wrote this equation based off the information we had for Randy. Like now we need to write an equation that represents Greg's constant speed. Make sure we take into account that he left before Randy. So it says constant speed again, and it's that same equation that we said. It's going to be miles over minutes. We know that he ran those 4 miles in those 32 minutes. Do I need to simplify? That means can I divide by the greatest common factor? And the greatest common factor that they have in common is 4. That means I can divide by 4. 4 divided by 4 does give me 1. 32 divided by 4 does give me 8. So I know 1/8 is going to be my slope in my equation. But it does tell me to take account to the 20 minutes that he left before Randy. So that means in those 20 minutes, he also had that constant speed of running 1/8. So the way I'm going to be representing that in my equation is that y is equal to 1 over 8. So that is his constant speed. We know it's determined by how many minutes he's actually running. but he also ran for those 20 minutes at that 1/8 constant speed. So I actually want to keep my minutes together, which is x plus 20 inside the parentheses, because eventually I do want to distribute that 1/8 over. But for today, I want us to leave our equation like this. So our equation does represent for miles is determined by this equation 1/8 x plus 20. Look at this problem says, will Randy catch up to Greg? If so, approximately when? So I know that Greg left sooner than Randy. So the red line is going to be Greg next to that line. So I know that it represents Greg. This blue line is going to represent Randy. So I'm going to put an R. And I want to know where they're going to intercept, meaning that is when they both meet at the same time. So I noticed they actually intercept right here. And I see has the coordinates of 70, comma, well, it's between 10 and 12, so I'm going to say it's 11. But what does those numbers actually represent? Well, I know 70 is my x value, and my x value represents minutes. And then 11 represents my miles. So I want to form a sentence for the meaning of this coordinate. I wrote the sentence saying that Randy will catch up to Greg in 70 minutes. So I grabbed the 70 from my coordinate plane right here. 70 minutes, or in 11 miles. So what I did in this problem is I see where they intercept. Where they intercept is actually my solution, aka my answer. So I wanted to know what that 70 represents. And we notice that 70 represents minutes because I read what the graph was telling me. It is my x axis, and my y axis is talking about miles. So we know we are talking about 11 miles.